In lesson 12.2, we're going to add, subtract, multiply, and divide radical expressions. And we'll start off with adding and subtracting radicals. The first thing we're going to look at is when we're adding and subtracting that we have to make sure that the radicals are the same. If I had like terms, 4a plus 7a equals 11a. So the same kind of an idea. So we just had to make sure all the radicals were the same, and then we're just adding the values that are in the front. Sometimes our radicals aren't going to look like we can add or subtract them, and sometimes we can't. But if we can, we're going to look at our radicals and say, I wonder if I can factor out find a perfect square and then take that out. So we could actually factor the 125 to be 25 times 5, and then we were able to take out a 5. Now we have the same values under the radical, so we're just going to subtract the 5 from the 8. Okay, so that's pretty easy. For multiplication, we're going to multiply what's inside the or underneath the radical, and then we're going to simplify it. So for this guy, of course, 10 times 8 is 80, and then we take the 80, and you might start off with 16 times 5, so then we know that 16 times 5, and we can find the square of 16 is 4. But some of you might have started off with maybe 8 and 10. Neither one of those are perfect squares, so then we might say 4 and 2 and 2 and 5. So now we have 4 times 2 times 2 times 5. And you could go all the way to prime factorization, but I stopped at the 4 because I can, that would be a 2. Then I have 4 times 5. That would be another 2. And we get 4 square root 5. So even if you don't start off with the best factorization at the beginning, eventually you can get to the same answer. Here we have where we're distributing. So square root of 3 times 7, square root of 3, and then remember we multiply what's underneath the radical. That gave us the 15. And we could look at it if I use variables. We would get 7a, and then that would be our AB. And instead of AB, we have 15, which is 3 times 5. So similar. Okay, we're going to have to rationalize our denominator. We don't want to have a radical in the denominator. So for this one, we had to multiply by square root 14 over square root 14, which is just another form of 1. By doing that, 7 times square root of 14, and then square root of 14 times the square root of 14 is 196. So it's the square root of 196, and then the square root of 196 is just 14. So it's always just going to be the value that's underneath the radical. Then, once we do that, we ask ourselves, I wonder if I can simplify it a little bit more. And so we look at the 7 and the 14, and that reduces to square root 14 over 2. All right, now we're going to look at a little bit more complicated denominator. And sometimes we're going to have to use our conjugate. So a reminder regarding conjugates, if we started off with 4 plus square root 7, the conjugate is the exact same expression except we have the inverse operation. So here we started off with a negative, so the conjugate is going to have a positive or a plus sign. So let's take a look at an actual example. So we can't have a radical in the denominator, so we're going to multiply by the conjugate, and the conjugate of 3 plus square root 2 is going to be 3 minus square root 2. And again, just like on the previous slide, we have to multiply the numerator and denominator because this is a form of 1, so we're really using our identity property. And then you're going to see a pattern, but we can FOIL this. All right, so if we FOIL it, we end up getting 9, negative 3 square root 2, positive 3 square root 2, minus the square root of 4. Then our middle terms cancel out, so we're left with 9 minus the square root of 4, which is 9 minus 2, which gives us 7. So we got rid of, or eliminated, our radical. This one, we cannot say 12 minus 4, because if you remember from about 2 slides ago, it would have had to say 12 square root 2 minus 4 square root 2 in order to combine those. So this is the simplified answer. That's all we can do for that one.